Example 4, the percent of American males between ages 18 and 24 who are no more than X inches tall is measured using this function, M. And the percent of American females between ages of 18 and 24 who are no more than X inches tall is measured using this function, F, where M and F are percentages and X is the height in inches. Use the graphs to determine any horizontal asymptotes of the function. Interpret the meaning in the context of the problem. So we're graphing, locating asymptotes, and then interpreting their meaning. So if we head to Desmos.com and type in our two functions, so here I've got the male equation, and then here I typed in the female equation. So male in red, female in blue. And then what you'll have to do is zoom out because I had to get it all the way to, I can't, yeah, here we go. I had to get it all the way to 100 by 100 there. And then maybe you can see. All right. So what we're seeing here is the female curve is a little further back on the x-axis than the male curve. And when they said x is measuring the height, that should make more sense that men are on average taller than women. So the male curve is further right than the female curve. And it wants us to look at the horizontal asymptotes of the function and interpret their meaning. So I'm seeing a horizontal asymptote at 100. What this does is it gets really, really close to 100 and it'll go up to 100 but not over it. So 100 is where we're approaching. Same thing with this line. We can see the values are getting to 100. And I'm not quite sure if they're actually equaling 100. It's probably the program just rounding up to 100 because it's such a big number. And then we see another horizontal asymptote here at 0. And again, I think these are getting so small that they're rounding to 0. It's not actually equaling 0. And then same thing for the male curve. Or no, this is the female. Female curve is going towards 0. So we're being asked, horizontal asymptote is 100 and 0. Why would it be 100 and 0? What does that mean in the context of this problem? So what I would say is the 100 is because we're talking about what percent of Americans. So we're talking about percentage here. So you can't have over 100%, and that is why it is curving up towards 100. And you can't have lower than 0%, which is why it's curving down towards 0%. So really, the asymptotes are referring to the percentage. And so that's what I wrote here, that with each curve, it's going up towards 100 because you can't go higher than 100%, and down towards 0 because you can't go lower than 0%. Then it asks for the average height of each sex. So by average, I looked for the 50%. And so if I go back to Desmos, I looked at 50% and saw what's happening at 50. Let me put an equation for 50 in there. Okay. So at 50%, I'm getting these two heights. So for the male curve, I'm getting 69.71. And for the female height, I'm getting 64.51. And so 50% of the population is going to be lower than the 69.71. And then same thing for the female, 64.51. So what that's telling me is that the average male height is about 5'8", and then the average female height is about 5'3", which makes sense. So that's what we have there for the average. All right, and then in example 5, An object at a temperature of 160 degrees Celsius was removed from a furnace and placed in a room at 20 degrees Celsius. The temperature T of the object was measured each hour H and recorded in a table. And after the table was created, we got this model from the data. Use the graph to identify the horizontal asymptote of the model and interpret the asymptote in the context of the problem. Well, I graphed it on Desmos, and this is what my graph looked like. And so it looks like I have a horizontal asymptote at 20. And so horizontal asymptote at 20, they want us to put that in the context of the problem. If we think about the object that's removed from the furnace, and if the room is 20 degrees Celsius, it's never going to cool cooler than the temperature of the room. So it's curving down towards 20 degrees Celsius, which is room temperature. It then says use this model to approximate the time when the temperature will be 100 degrees Celsius. So let's do that. So I'm looking at part B. So they gave me an equation. And they want us to figure out how long, time, so H is what we're looking for, if we make T 100. All right, so we're going to simplify this. Divide by 20 first, and you're going to get 5. And then we need to get everything away from this 2 to the negative H. So I'm going to subtract 1 to the other side and divide by the 7. And now there's no way to get 4/7 to have the same base as 2, so we're going to change it into a logarithm. Log base 2 of 4/7 equals negative H. If you type in log base 2 of 4/7, you have to use change of base formula. So you'll have to do log of 4/7 divided by log 2. And you get approximately 0.8073 hours. Well, negative, and then you move the negative over. And that's in hours. If we want to figure out minutes, we could just multiply that by 60. So that is approximately 48 minutes that it would take to get to 100 if we're taking it out at 160 degrees Celsius.